Good morning, everybody. Having a hard time recording a blog. This video, I tried 3 times. I don't know how people fucking record everything, but trying to go through my journey as a business or developing my business. So, Sunday, December 22nd, about 9 a.m. Typically, I wake up early, but I was up late. Gonna go through my morning routine, get my prayer, get ready, eat breakfast. I don't know if I have. I'll try to go to the gym after in the afternoon. I don't know, maybe I'll go earlier. Fuck. I gotta sell something on Marketplace at 11. Somebody wants to pick up one of these items I'm selling. But yeah, I got some plans for today for the business. I spent yesterday thinking about what I should do for 2025 to really help grow my target audience. Not target audience, but grow the awareness of Influx Labs. So thinking about what are my strengths, what are my weaknesses, and what can I really do to get more attention to my company and my brand. So I have an interesting project idea that I wanna pursue. I think it'll be pretty awesome. So I'll be in the office today at about noon, and I'll tell you guys about my idea and what exactly I plan to do, and it's gonna be, I think it'll be pretty cool. Stay tuned. I guess I might give you guys just a update on my life as a founder and mechanical engineer while I make some chai, because I love chai. And it's I don't know for those of you not familiar with chai, it's basically an Indian form of tea. It's black tea with sugar, milk, some spices. So yeah, but I started Influx Labs 2.5 years ago, and it's been quite a journey, to say the least. It's been one of the most difficult things in my life. And there are other personal things that I've been through, but starting a company will just completely shift your perspective on what difficulty is. Especially when you don't have any funding and you're self-funding and it's your money on the line, and etc., etc. So yeah, I started it 2.5 years ago. Before that, I was working with my dad, and so he and I were making a company to do custom gear manufacturing. So he's an expert on gears, and we built this whole CNC machine to make gears of different profiles, etc., etc. And I just finished my master's program and started working at KLA 10 Core here in the Bay Area. So, and I was working with him on the evenings, just helping him build his business. And about 2.5. So about 3 years ago, we started getting an order for some gears, and we finished one order, but the order also had some mechanical parts in it. And we ended up not quoting those, but I figured, I'm a mechanical engineer, let me try to do this order and figure out how to make CNC parts. And I wanted to start my own business as well, to be a little bit separate from what my dad was doing. So I ended up starting Influx Labs as a CNC machine shop that focused on working with medical devices. So I've got two machines, a small mill and a lathe. At this point, I didn't have any facility. Those machines were sitting in my mom's garage, and I didn't really know anything either about CNC machining. So it was quite a journey learning just how to make a part and what the process is for CNC machining. But yeah, we were in my mom's garage, and even before I got the machines, I went to a trade show, MD&M West. I figured, how hard can it be? So I took some CNC machine parts and I just advertised myself as a CNC shop without having any equipment actually in my shop. So in my shop being a garage for a house that my mom, me and my mom were living in. So anyway, I went to this trade show and I met some pretty interesting people. So the trade show is the MD&M West trade show, the largest medical device conference. And I figured I really wanted to go and exhibit for my dad's company because I thought it would be a good way to get the word out there for these gears. But I had a little bit of a falling out, and he didn't want to go, and I thought I really wanted to go, and so I ended up just signing up under my company, Influx Labs. I've had this company this LLC for about 4 years now, and I never really knew what to do with it. I started it, so the actual legal company name is PS Technologies LLC, and Influx Labs is a trade name. But I've had it for about 4 years, so then I said, I'm just going to go under my company. So I went under Influx Labs. I set up a whole table and a whole booth. And it was a pretty interesting story. I might save that for another video. But anyway, we were there, met some interesting customers, and then actually got about 300 leads. Cultivated those leads, started getting some orders. The machines came in, and we figuring out how to use those machines to fulfill these orders. So eventually I said I can't really work in my mom's garage, and I'll go through that whole ordeal in more detail in a different video as well, but it was just becoming way too much. So I got a little shop in Milpitas right across from my job as a mechanical engineer. We moved the machines there, and then that's the story of Influx Labs. And ever since then, just been a lot of ups and downs for the company, and it's now about 2.5 years in. It's relatively new. Right now, it's just me. I have one contract worker that comes to help make the parts whenever he's free, and yeah, that's the story of my company. So I mean, in short, I focused on it full time. I left my job. Then I ended up going through a really tough time, not getting any work and this and that. So then I flat broke. So then I started working again, and now I'm back at working as a mechanical engineer, and I'm taking my approach to business in a more smart, in a much more thought out and methodical way and an approach. Previously, when you start a business, I realized, I'm only 2.5 years in, but I realized in the beginning it's scary and things are uncertain. You have little money in the bank, and especially I don't have any backers, so I'm funding this, right? So I bought all the equipment, this and that. So in the beginning I realized I was scared a lot. I was making a lot of wrong choices, losing a lot of money, and I was unable to handle the stress, and it led me to make bad decisions, because stress leads to bad decisions a lot of times. You want to make, especially if they're major decisions. So that happened. I left my job, which was one of the worst decisions I could have made in a business, and then now I'm back, and so I'm not familiar with really posting content on YouTube or really doing any of that, but I know I need to grab attention somehow towards my company, and I got to do something that makes me uncomfortable. So here I am. I've never done a vlog in my life, or really anything. I feel stupid hearing myself talk, but that's how it is. But anyway, I was up till 2 a.m. last night, and I was thinking about, okay, what can I do to have a steady stream of content for Influx Labs that will differentiate myself with my competitors? And what I was thinking is, my main edge against my competition is my engineering background and my skills, right, as an engineer. And those would be, that characteristic would also be my target audience, are younger engineers, mechanical engineers looking to build their projects. And so robotics has been a big topic of mine for my master's. I built a 5-axis robot that I wanted to use as a platform for a surgical robot. And a lot of flaws with that platform, but I'm thinking, I have an idea for a robot that I could build and just document that journey of the process. And so I don't want it to be a hobby type of DIY robot project. I want it to be something professional. Eventually I plan to productize this, but one of the things that I think could help me in my business is having an automatic loader for my CNC machines, but something a little bit more innovative and small scale. So here I'm gonna, I don't even know how to flip the camera. That's how you know I'm so stupid. But anyway, my chai is boiling over. For those that know how to make chai, when it starts boiling when you add the milk and it goes all the way to the top. Hold on, I gotta take it off the stove and mix it. But anyway, what I was saying is I want to design a robotic parts loader for my shop, and it's gonna have a very specific, I want it to be very easily integratable with my setup. I don't want to have a big pallet system. I mean, it'll be for jobs that are about 50 pieces for batch size, etc. So I want to build something that's practical. I mean, there's no point. I thought about it and I was like, I'll build a robot, but there's no point in building a robot that I can't even use to make money. Otherwise, it's just a whole expenditure of resources. But essentially, what I think the robot will do is I'll show you more detail when I'm back in the shop after I get ready. But essentially, the vise will be here. Let's see, the vise is here, and then I want the robot to take the piece of stock. So stock is just aluminum or steel, rectangular shape, or circular. So it depends how. But I want the robot to just take the piece of stock, put it in the vise, and now to clamp the vise in a repeatable manner. Now I was thinking about, okay, I don't know if the robot can clamp the vise accurately, but I can make a electronic vise that clamps to a specific torque value, because machinists, they do a lot of this stuff by feel, and it's pretty damn amazing. My expert machinist, basically, if you clamp it too tight, the stock warps, right? I mean, it deforms in the vise, and when you start cutting stuff, you get mismatched dimensions. So you got to clamp it just right and just the right amount. And I was thinking, how the hell do I do this? And I have an idea. So that'll be the second part of the project. So the first part of the project is to develop the robot that will pick up the stock and place it in a little vise. And I'll show you the work area, but that's going to be the project I do. And I think the tough part of all of this is I am a mechanical engineer in my day job. So 9 to 5, I'm going to be doing that. And then on top of that, I got to focus on my business operations. So I think I'll have to do a couple hours of work on this project every week. Maybe every weekend I'll dedicate 4 hours on Saturday, 4 hours on Sunday. And then that's when I'll post all the videos. Maybe during the week I'll post videos of just business topics that I encounter, certain business difficulties. But yeah, that's the project that we're going to start, and it's going to be pretty cool. So like I said, this is not going to be any DIY hobbyist type of stuff. I'm a full-blown engineer at a semiconductor. We build some incredible things. So this is going to be a professional design project. I'm going to put together all my content in the same style of design reviews that I would go through at a Fortune 500 company. I don't know who the hell I'll present the design reviews to, because it's just me, but maybe I'll present it to you guys and do some mock design reviews that you guys can kind of see how it's done in the engineering world here in the Bay Area. But yeah, today the plan is, after I finish my breakfast, which is some chai and boiled eggs. Actually, I need to put some salt and pepper on this. But my plan is for today is going to go through all the requirements for the project, put that in a spreadsheet, and then also look at current systems on the market and the flaws and pros of those systems, existing systems. Then I'll put that all together in a couple of slides and really flesh those out. So one of the main things as an engineer is you really have to define your requirements clearly before just starting anything. And I've gotten burned on this so much because of a misunderstanding of what I'm designing to. And you don't want to design something that's not needed either. So you want to take the time to really go through what requirements that you're designing for, as well as what the actual problem you're trying to solve is. And so what I'm going to do today is we're going to go to the work area, and we're going to measure, the reach that's needed for the robot and the payload approximately, and other different requirements that are needed. We're going to put that in a spreadsheet. And on top of that, we're going to look at existing solutions, look at those models, the pros and cons, the CAD models of those, pros and cons, and then also put that in a spreadsheet. And then that's going to be a starting point on this project. And then we're going to narrow down everything, flush it down, and then I'm going to present a requirements review to I don't know who, maybe a stream or something, to anybody who wants to join in. But it'll be a review of the requirements. So in the design process, you typically go through your requirements review. You have a detailed review of all the requirements you designed for. Then you go to your conceptual design reviews. So after you review the requirements and you say, okay, this is good, you get sign off and approval from all the stakeholders of the project that these are the requirements of the project. Then you go into your conceptual design review, where you start sketching up some concepts and maybe starting doing a little bit of CAD, but no detailed CAD work yet. You start doing a conceptual design review, just concepts. Once you go through that, you will probably go through a couple concepts with your peers, get feedback from the principal engineers, and then what you'll do is you'll lock down on a path to follow. And the path you follow will be agreed upon by everybody in the project. And you say, we're going to go down this path. Then the next stage is your detailed review, where you start designing up the system, going through all the calculations. And then you present all those calculations. And you may have multiple of these reviews, but then you go through your detailed design review. And then you get feedback from people that have done this before, know more than you on your design. You'll take that feedback, implement it into your design. Then is when you'll start to cut metal and actually make the parts. And once you make the parts, you put it together, test it, then you have your validation or verification. And you'll present that in your report and just say that, okay, we built it, this is the problems, this is how we're going to fix it, or we built it and it worked. And you know it works by looking at your requirements and then looking at what you've built and saying, this matches my requirements. And so that's why the requirements are very important. So today, and probably the first couple weeks, so I'm only working on this about maybe 2-3 hours on Saturday, 2-3 hours on Sunday, because I have another project I got to do today as well. But today and the next couple weeks are going to be the first flushing out our requirements for this project. So I'll see you shortly. Let me eat my boiled eggs and chai, and I'll see you guys in a little bit. I don't know. Also, I don't know who is watching this, but if you have any feedback on blogs, on the length, I'm just doing this shit unedited. So these are going to become quite long. I already see that this is freaking 18 minutes of talking. But I might just post, when I post this video, I'll probably have bookmarks or something to help or like, I don't know, those things that are called which mark milestones of the video. I'll implement those. But all right. See you in a bit. Let me finish my breakfast, and then I'm gonna give you guys a call when I'm at the office after I get ready. Hello. Just arrived at my shop, and yeah. So, let's get my stuff from my car. Okay. Let's see. Figure out how to flip this camera. Alright, well, anyway, Influx Labs. It's my shop. Got key. Alright. And yeah, so not sure if you guys are familiar with CNC machining, but my company does, basically we take solid material, billet material, and machine it into different parts that people may need for their designs. So that's the gist of my company, and can't show a lot of the work. Actually, I'm a little iffy on what I want to show because stuff's under NDA, but let me see. So for example, this is another part that we made on a machine, and this was for my project a while back, but it's blue because it's anodized, so it's aluminum, which is basically plated. So it's aluminum that's put in a bath, oxidized, and it has a hard outer layer that's scratch resistant as it oxidizes, and then they put some dye in it to make it blue. So this is blue anodized aluminum, but you could see there's holes on the sides, holes on the top, there's a little step, etc., etc. So we make this type of stuff here at Influx Labs. And then let me see if I could find something else. And then also there are cylindrical parts like these. These are done on a lathe. So you imagine this comes with from a rod of steel, and then the rod of steel turns very quickly, and then you have a cutting tool that skims off material and it's basically cuts this profile here, and then there's a thread on the back here, if you could see. So yep, that's what we do. So I have one little side quest I gotta do right now. Let's see what time it is, 10:50. So I gotta sell something on Facebook Marketplace. So I'm gonna go do that really quick. I have a meeting. Sell this little thing for 20 bucks because it's been sitting for a while. But then after I complete that little side quest, I'll come back to the shop and drop off my stuff, and then we'll go over the robot loader, and basically I'll show you guys the CNC machine and what I'm designing. All right, I'm back in the shop. Just gonna summarize. Here's the mill, here's the workstation. Goal is robot sits somewhere here, takes the piece of stock. This is what the stock looks like. It just could be this in different sizes or variations. So right, I mean, this is a larger piece, but it needs to take the piece of stock, place it in the vise. Obviously needs to open the vise, and then the robot needs to come here once it's placed in the vise and clamp it with the handle or something, or the vise needs to have to communicate with the robot to clamp itself once the stock has been placed. So I can already see a couple of problems. So if you turn it vertically, so you see I can't have the robot perpetually sitting here because my machinist needs to work here, and when we're doing one-off parts, he needs to have all this space clear. So I'm thinking maybe we put the robot on wheels or something, and actually running on that point, let's say it's if it is on a cart or something, we can have my operator cut stock on the bandsaw, put it on the cart, and when we want to enable the robot, we move the cart here, teach it how to put, move the robot, teach it to place the stock in the vise, and then set start. So something like that is, or probably. So something like that is what we're probably gonna do. At least that's what I'm thinking right now. And we'll be working on this about 4 to 8 hours every weekend. We're gonna go through the thorough, full design review process. So today, I'm gonna put together some requirements, look at what existing on the market. So let's see, currently it's about, I don't know if my watch is slow or fast, but it's about 11:30. Sorry, my watch is an hour off for some reason, but it's 11:30. I'll spend about 3 hours. I got some other work I got to do, so I'm gonna spend about 3 hours scoping the requirements on this thing, and I'll put that together in the spreadsheet, and maybe I'll share that. I'll go over, before I stop working to move on to my next project, I'll go ahead and share what that looks like. So I'm gonna get started on that. All right, so I'm taking some measurements just to see what the initial size of this robot would be. So I imagine the robot will kind of sit around here at this position right here, and from there to the center of the vise is about, let's just call it an even shit. Okay. Let's call it an even 40 inches. So basically, we need to be able to, so the cart would sit about, center of the cart to the center of the vise would sit about 40 inches. Plus you need a little bit of range, let's say if the vise is varying somewhere. Perhaps it's this or that, but let's assume 40 inches, because the other thing we could do is move the machine. So we could move the machine table all the way up during the loading position, but I don't know how much that's is. So let's just call it an even 40 inches right now. And okay, so the height of this thing, let's see how tall it needs to be. I'm gonna, like I said, I'm not really a pro video expert, but this opening here from the door is 32. I don't know if you can read that, but about 32 inches. Hold on, let me flip my camera. All right, so measuring the door opening. So this is, it's called 32 inches tall, and when the door is completely opened, let's say 24 inches wide. So it's a small door. So I'm gonna write that down. We got our door opening is 32 inches tall by 24 inches wide. And then, expanding on that, let's see that the bottom of the door distance to the ground. So the bottom of the door sits 30, it's called 38 inches off the ground. So, bottom of the door is 38 inches off the ground. Okay. So, now the other thing I just thought of when doing this is the robot, well, if we leave the door open, right, then when the parts are running, I mean, you have coolant that gets ejected from the coolant nozzles and it makes a complete mess. So the robot has to close the door. So I guess that's going to be a functionality when you look at it. So we're gonna have to close this door and this door. So maybe I'll need to load the part in, come here, and let's say close this door first, and then this door, and then needs to keep it shut. I might need to do something on this, but right now the robot should be able to do that. Grab this door, grab that door, shut it. That should be pretty easy. But then now I need to think about travel requirements to do that. I don't know, I'll deal with that later. But okay, so essentially our reach. It needs to close the door after placement, and then the other thing is it needs to hit cycle start. So that's gonna be a little tough. If you look at, I mean, this thing, when it's running, I'll show you that probably a little later, but there's a cycle start button. I don't have a physical button, it's a mouse. So perhaps I can do a shortcut key or something. I have to look into the Path Pilot console, but so I'm just gonna make a note of that. So after robot loads part, needs to close door, then after door closes, needs to hit cycle start. All right, so assuming I can do all of that, I think that's about the flow. So just to recap, basically we're thinking the robot will be on a cart, so it's mobile on a cart, and it'll be wheeled from the bandsaw in front of the machine, and I can have marks on the floor approximately where the robot should be placed. Load from saw to machine, and then once it's done that, it needs to, it's gonna be tough. Yeah, it'll need to open the doors. So it'll need to open the doors, put the stock into the device, close the doors, hit cycle start. So that's about the flow. So open machine doors. All right. Yeah, as we get into a little bit of details on this project, I can see it becoming a little bit tougher. So then we need some mechanism to know whether the door is open or closed of the CNC. Perhaps it could be a vision sensor. I mean, I don't want to do anything really fancy on computer vision or anything. That's not my expertise. But maybe we could just have a door open sensor, and if it's, yeah, it just senses it could be something simple. So anyway, needs to open the machine doors, put the stock into the vise, or well, it needs to open the vise, put the stock in the vise, close the vise, close the doors, hit cycle start. So open machine doors, open, vise, place, stock in vise, and close doors, hit cycle start. All right. I think that's a good starting point for now. So I'm gonna put all these into my spreadsheet, and then perhaps, yeah, let's keep it going. Hello everybody. Okay, so what I'm gonna do right now is go over some of the initial thoughts I've done while just looking through the requirements. And essentially, this is the machine model, thanks to Tormac for providing this for us. But I've downloaded that here, and then here's just a sample cart that I looked at with Master, and I just modeled up the dimensions. So what I've done right now is I've looked at some of the existing systems on the market, and you can see right here there's a couple I've listed. So there's this AR4 robotic system by Annan Robotics, which you could go over here, and this seems pretty interesting. So I'm going to do a little bit more research in here and basically get a little bit more of a feel for what the system is. There's that, and basically what I've listed here are just open source robots that I could find and piggyback off of. Then there's these Elephant Robotics arm, which is it's pretty interesting, but these are incredibly small in small robotic systems. And then there's this Thor robot, which I've looked at, and I haven't gotten a chance. But one of the arms that I looked at that was really impressive is this one called Dummy. He calls it Dummy Robot, but it's this YouTuber from China named PZ, and some really interesting stuff on this project that he's gone through. But essentially this was a really, really interesting project, and I was looking at this, and then basically he has all the files on GitHub. So what I did is I went and downloaded some of them, and then I could tell right away here's going to be the problem that I see. So this is his arm, and I need to look at how it compares to some of the other ones I found, but a lot of them are around this size. And you see the scope that needs to happen is the arm needs to be able to reach into here, put the machine on, or put the part in the vise, and then the device needs to clamp it, or the arm needs to clamp the vise, etc. So the scope of this project is going to be much bigger, and I encourage you guys to check out this Dummy Robot by PZ. It's pretty insane, the stuff he's done. It's in Chinese, so you have to pay attention to the subtitles, but you can already tell this is going to be a main problem. Is a lot of the open source architecture is relatively small compared to what I'll need. But you can see that here, and I've also just began compiling the requirements in a Google spreadsheet. So here are the high-level system requirements, and I mean, starting just from what I'm thinking is the payload needs to be at least 20 pounds, and these open source robots are too small. They can do about maybe 5 pounds max, where I think that might be too little compared to some of the bigger pieces that I machine. And then obviously it needs to be compatible with the door, and it needs to be movable on the cart, and then I've done through the workflow. And so one of the things that I think is gonna be tough is, okay, we wanna do a $2,500 budget for this. I mean, cause I'm self-funding this and I'm gonna be building this. So let's see what we can do. Repeatability, for placement repeatability should be 0.1. I mean, this is a big system. Smaller systems, it's much easier to be higher, but I get a tighter repeatability, but this is gonna be pretty big. So I think we're gonna stick with 0.1 millimeter. 60 OF is what we're gonna go for. And so I need to figure out how we're gonna operate this, but basically it needs to be teachable, so the operator, the machine operator, should be able to use this relatively easy. And then the weight, I need to be able to move this robot cart assembly, and then the water, it needs to be watertight because we are gonna be using coolant. So yeah, I'm gonna continue working on this, but I just decided to share you guys a little bit of what it's gonna look like and the scope of this project. So I'm gonna be working for another, I need to eat some lunch, but I'll work for about an hour and an hour more after lunch, and then I gotta move on to some other stuff I'm doing. But I'm gonna see if I can put together just the basic geometry of the robot so I can get the approximate size requirements, and then we'll go from there. All right, stay tuned. All right, so what I'm gonna do is probably call it a day after this, but essentially what I have here is the basic size profile. So here's the cart, here's the machine, and then you see those are the shoulder, elbow, and then the wrist, and the base. So obviously there's going to be a turning in the base, that's the first degree of freedom. There's going to be the rotating from the shoulder, that's 2, the elbow, that's 3, then there's going to be this wrist rotation, it's 4, and then there's another wrist rotation here, that's 5. And to make it 6, I need to look at the architectures again, but I believe there's an intermediate roll here, or yeah, I believe that's what it is. There's a roll here, then there's the pitch here, and there's another roll here. So anyway, I'm still mocking it up, but I think this is going to be the scale of things, and to put that into perspective. So this size here is about 18 inches. 18 inches, it's a foot big, so it's going to be a pretty big arm. And the limit, so I'm machining everything on this Tormac machine, right? That has a travel of about 14 inches. So that's going to be another problem. All the parts are going to have to be designed within that travel distance. Or I'm planning to get a new machine end of Q1 next year, so if that works out, maybe I can use that for some of these bigger parts, but let's see. So yeah, I'm gonna log off now and get some lunch. It's about 2. I don't know if I'll have time to work on this anymore today, but probably this week I'll check in again. I got the 24th and 25th coming up, Tuesday and Wednesday, so I have those days off of work, so I'll make some more progress and check in. But after this, I need to just upload these to YouTube, and I'll get some lunch, and then I have some other things I gotta focus on. But anyways, thanks for checking in, and it's been cool. I think I'm pretty excited to start this project. So that's about the scope of the work I'll do this weekend. I think what I'll do is I'll do every weekend. I'll post on YouTube, because I'll need to I won't do much editing, but I'll just clip everything, or just put everything together and upload it every Sunday. So then you'll see the progress every week. So we'll call this week 1, just initial architecture requirements. I think week 2, I plan on diving down on those requirements and getting the spreadsheet, and then maybe sizing some of the joints and what we plan to do. for the robot joints, and then we'll probably also put together a project timeline. So pretty exciting. I think goal is to have this done end of 2025. So take a year and be on the market. So have it as a product end of 2025. All right. Thanks for tuning in. See you guys next week.